All right, last piece here, 127. All right, so 127 is kind of just really taking a deep dive into an inverse, the domain and range that's associated with it, so on and so forth. So it says, think of a function that squares any number and if possible, takes the reciprocal of that number. All right, so really need to know what we're talking about each piece. So if we're saying that it squares any number, so that means it's taking some number and it is squaring it. So that's your first piece. All right, and then if possible, it takes the reciprocal of that number. So then the reciprocal, you're thinking 1 over x. That's what reciprocal means. You're taking whatever number. So what is the final formula going to be? It's going to be f of x is equal to 1 over x squared. So that's the function we're going to use for this. Then it says, what is the domain of this function and is this function invertible? Why or why not? So if you're thinking of a reciprocal function, remember, you have to think, what can my domain not be equal to? Your domain, your denominator, all right, is where we're going to look, cannot be equal to 0. So what number can you plug in and get 0? So in this case, our domain is just going to be y cannot equal 0 because I can't take 0 squared and get 0. 1 over 0 does not work. And then is this function invertible? So for you to see if a function is invertible, all right, you have to think about, I think the easiest way is to decide what, again, is it 1-to-1 or not? So the graph of a squared reciprocal, all right, when you plug in negative x values, you're going to get positive y values. When you plug in positive y values, you're going to get positive, or when you plug in positive x values, you're still going to get positive. So your y is definitely not going to be negative, and your y and your x's cannot equal 0. So you have this vertical asymptote here, all right? Zoom in just a little bit. So you're going to get one piece that looks like this, one piece that looks like this. So is that a 1-to-1 function? No. So is it invertible? No. So no, because not 1-to-1 or injective. Either word. You don't have to write both. So then it says, define a subset of the domain where the restriction of this function is actually going to be invertible. So again, going back to that graph, we have to make it a 1-to-1 function. So that means I can either restrict the domain here or I can restrict the domain here. Either one would be fine. And in this case, because like what I told you on 126 is you want to pick the restriction that's going to give you the most information, this is going to be equal no matter what you pick. I'm going to restrict the domain over here because I like to work in the first quadrant because it's positive as opposed to working over here and having to work with negative stuff. All right. So define a subset of the domain where the restriction of this function is actually going to be invertible. Write the smaller domain down and then say what the range of your new graph is. All right. So now the domain that we're going to work with is just 0, not included because it's that asymptote, to infinity. The range of our graph is still 0 to infinity. Question 4, I challenge you guys to think about what that's going to look like. So this isn't, you're not expected to know right off the bat what it would necessarily do, but you want to think about inverse operations. So if I'm telling you that the function is squaring the input, the inverse operation of squaring something would be to square root something. And then it takes the reciprocal. So what do you think that reciprocal is going to do? Like, what's the opposite of taking the reciprocal of something? Inverting it. Taking the reciprocal again, or what do you think? And if you don't know, then question 5 is going to be where you really can kind of see it. So if as far as you could get was that it's square rooting it, then let's go ahead and do question 5, and then you can really see what the inverse function is doing. So it says, write the equation of the inverse function and record the domain and range as well. So to find your equation, you take your original and you flip your x and y. So now we have x equals 1 over y squared. So if we were going to start to solve for y, we need to get y out of that denominator. Oops, squared's up here. So we're going to multiply by y squared on one side, multiply by y squared on the other side. So this side cancels, and I'm going to have y squared times x is equal to 1. Then I'm going to divide by x, and I'm going to get that y squared is equal to 1 over x. And then the last thing, to get rid of that squared, I'm going to square root, and I'm going to square root. Now, because I chose to work just in the first quadrant, I don't have to pay attention to the negatives. Usually you have to take the positive and the negative, but because I restricted the domain, I'm only going to look at my first quadrant. And then it asks you, what's the domain, what's the range? The cool thing about domain and range is it's going to take your original and it's going to invert those also. So if you're looking at the domain of this function, you're thinking, okay, my denominator can't be 0 and I can't take the square root of anything negative. So my new domain is going to be 0 to infinity. And my range, whenever I'm taking the square root of numbers, I'm never getting negative numbers back. So this range is also going to be 0 to infinity. So then question 6, were there other domain restrictions that you could have tried? How many different ones could you have done? All right, so right off the bat, an easy one, instead of picking the positive side, we could have picked the negative side. So possible domains could have been negative infinity to 0. And then are there any different ones you could think of? So if I'm thinking of other ones, yes, there's endless amounts of ones you could do. All right, because if I'm saying that negative infinity to 0 works, well, so does negative 10 to 0. So does negative 5 to 0. So does negative 10 to negative 5. Like, there's tons of different ways you could have restricted the domain. We just kept it as big as we possibly could, so you're getting the biggest picture possible. So infinite amount of possible domains. And so then question 7 is going to be the question that I leave you with. This is going to be the question we talk about when we come back tomorrow. Can you think of a function that won't be invertible no matter how many times you try to restrict the domain? I mean, go and go and go and go. No matter what you do, there is no way that you could make it an invertible function. So you guys kind of try to think about that, and we'll come back tomorrow.